Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super-powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guess said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new: a bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things: really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear: the typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet.
Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour, as faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did the zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space. Thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow. Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Quipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Quipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Quipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Quipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Quipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Quipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Quipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Quipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Paul Mazur and Emil Mottola, in 2006. They tried to think what else besides black holes could happen when a massive star collapses on itself. That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravistar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravistar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravistar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravistar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravistar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in space-time, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized If gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity.
Space. Dark, lifeless, and quiet, right? Well, apparently, it's not always true. Recently, scientists have detected an eerie echo coming from the main black hole in our galaxy. It has high and low notes and sounds pretty otherworldly. What does it mean? Should we sound the alarm bell, siren, whatever? Sagittarius A star is our own supermassive black hole, sitting right in the center of the Milky Way galaxy where we live. You might know that black holes are the true monsters of our universe, gobbling up everything that is careless enough to come too close. If a massive black star runs out of its star fuel, it sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing becomes so strong that nothing can escape it, not even light. And so goes a black hole. We really can't see black holes since they devour everything, even light. But we can still figure out where they're located, all thanks to the existence of accretion disks. Want an explanation? Well, picture a black hole. The starving thing consumes all the matter that strays too close, squeezing it into a superheated disk of glowing gas. The black hole also bends light around it, which creates a circular shadow. That's what I mean. We can't see a black hole itself, but we can see the accretion disk surrounding it. It happens like this. First, the material gets caught in the black hole's orbit and squeezed into a razor-thin spinning band. Friction, heat, electric, and magnetic forces energize this disk, which makes the material glow intensely. The most massive black holes have such bright bands that they can outshine millions of galaxies. Inside this disk of glowing material, particles rub against one another. It slows them down and sends them straight toward the black hole's event horizon. If this friction didn't exist, the material would be orbiting the black hole for billions of years, like planets circling around their stars. Now, let's get back to Sagittarius A star. It's far less luminous than other black holes at the center of galaxies astronomers have observed. It means that, at the moment, our central black hole isn't actively munching on the matter surrounding it. What, is it catching some Z's? The answer is unclear. There's new evidence received by NASA's IXP telescope. It suggests that the seemingly sleeping giant woke up pretty recently, about 200 years ago. Ooh, that is recent. It snacked on gas and all kinds of cosmic debris within its reach. Why did it happen? And what did the black hole do after that? Sagittarius A star is the nearest to us supermassive black hole, just 25,000 light-years away from Earth. Its estimated mass is millions of times greater than that of our Sun. It sounds impressive, doesn't it? So, when scientists spotted relatively recent X-ray emissions of ginormous clouds of gas in the vicinity of the black hole, they immediately called on the IXP telescope to figure out what it may mean. What intrigued them most was how bright these clouds were. You see, most cosmic clouds, called molecular clouds, are dark and cold, with their X-ray signatures very faint. But that wasn't the case with this finding. Of course, there are a few theories concerning this phenomenon. One of the main explanations for why these giant molecular clouds are shining so bright is that they just echo a long-gone flash of X-ray light. It could mean that our supermassive black hole might not have been that dormant some centuries ago. After additional research, astronomers figured out that the X-rays coming from the giant molecular clouds were actually reflected light. And this light must have come from a short-lived and extremely intense flare that was produced either very near or right at Sagittarius A star. And the most likely cause of it is the black hole suddenly consuming a huge chunk of the material surrounding it. It happened around the start of the 19th century. It was most likely a sight to behold. Whirlpools of particles were drawn toward the black hole's event horizon, also known as the point of no return. The black hole started to ingest all this material, which resulted in brilliant bursts of X-ray light and echoes that we managed to translate into sound waves here on Earth. This discovery is crucial for understanding the processes happening to and around our supermassive black hole. We might also figure out what physical processes can potentially awake Sagittarius A star again, even if this period of activity is just temporary. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times the mass of our Sun. And two such giants have been recently spotted with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, mercifully also known as ALMA. Two gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars tucked close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Interestingly, such immense merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe these bright and compact regions where matter swirls around black holes. Imagine how surprised they were when, instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. And if before, experts thought that such galaxy mergers didn't really happen in our neighborhood, this discovery may mean that black hole binaries like this one may be much more common than we previously thought. And if pairs of black holes are so common, it can make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide there are in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in about 4.5 billion years. Oh, I can't wait. Now, have you heard that we might be living in a black hole? No, I'm not kidding. Such a scary theory does exist. See for yourself. Black holes pull inside everything they see. But what if one black hole has already engulfed us long ago? Surprisingly, some physicists deem this theory somewhat plausible. For example, Dr. Nikodem Poplovsky, a theoretical physicist from Indiana University, states that everything that a black hole swallows may turn into a new universe inside the hole or on the other side of it. Who knows? Maybe our universe used to be a quite different place until it got pulled into a black hole. The theory of white holes is closely connected with the previous idea. While black holes swallow all the matter so that not even light can escape, white holes are something quite the opposite. These formations are believed to spit out everything that black holes have pulled in. In other words, a white hole is the hypothetical area of space-time that nothing can enter from the outside, but light and matter can escape from it. As for a black hole, on the contrary, you can only enter it from the outside, but can't get free afterward.
You know how galaxies have supermassive black holes in their centers? In most cases, we don't have to be afraid they'll come after us. They stay at the same spot for eternity, or at least until they start to evaporate and give the energy they have stolen back to the universe. But there's always that one rebel that spoils the statistics, like this invisible beast that ran away, moving farther and farther from its home galaxy. It escaped with style though, leaving a shiny trail of stars behind it, like a wake behind a ship. And it's moving really fast. If it was somewhere in our solar system, the moving black holes could cross the distance between our home planet and the moon in a mere 14 minutes. A regular spacecraft needs 3 days to do that. The unusual Space Wanderer weighs as much as 20 million suns and has left a trail of newborn stars 200,000 light-years long, which is twice the diameter of our galaxy. No one has definitely seen anything like that before. There are a few ways a supermassive black hole can run away from its home. One of them is when two galaxies come together in a big collision. As they hit each other, you get a pair of supermassive black holes that start dancing in circles around each other. If there's one more black hole that decides to join the party, it can give a big push to one of the dancers and kind of catapult it far away from the center of the galaxy. Another way is when the two dancers finally catch up with each other, align their moves, and become so compatible they merge at one point. This new black hole they create can get a push or a kick, and before it even knows it, it's somewhere far, far away from the safety of its home. This runaway black hole we're talking about is probably the result of many collisions of giant black holes. Their home galaxies probably merged around 50 million years ago, which brought these two together. Then, an intruder likely appeared, another galaxy with its very own giant space vacuum, and things quickly became chaotic. As one of those three tried to steal the moment from the other two, it ended up thrown out of the galaxy. The original pair may have stayed there, or maybe the guest took the place of one of them. Don't think it's always that easy to go after the rebel and talk it into going back home. It's generally really hard to detect black holes. Sometimes they give away their current position when they eat large volumes of stuff they find on their way, such as gas and stars. When they're full, they become very bright. But the rest of the time, they just eat a normal amount and hide in the eternal shadows of the cosmos. They leave traces when they come closer to objects in space. We may not be able to see black holes directly, but special telescopes can catch what they do to their environment. For example, we can observe a star that makes circles around something we can't see instead of orbiting its binary companion star as we'd expect. Scientists can measure how fast that star is speeding up and calculate the mass of the object that's pulling on it. And when the mass is so big they can't match it with anything they know about, it means it's probably a black hole. Also, special X-ray telescopes can recognize radiation emitted by a star that has come too close to a black hole, which is now pulling it apart with its strong gravity. Black holes have an accretion disk, which is like a swirling thing that orbits them, like a whirlpool. When stuff from their surrounding falls into this whirlpool, it gets very hot and starts shooting out X-rays. Supermassive black holes have a mass of over 1 million suns, so it's not surprising they shoot out gas particularly far into space, sometimes even millions of light years away. Anyway, our rebellious black hole was hard to spot, considering how it kept moving faster and faster. But unlike others, it's never tried to hide, considering that shiny trail of stars. It doesn't gobble up stars that are ahead of it. Obviously not a fan of Pac-Man. Poor fella doesn't even have time to stop and grab a quick bite. Instead, it's just plowing into gas in front of it, which triggers the formation of new stars along its narrow path. The gas probably cools and forms a trail that's nearly half as bright as the galaxy itself. The black hole sits at the top of the column that stretches all the way back to its parent galaxy. It seems like this runaway wants to mark the way wherever it goes, in case it ever decides to get back home. And over there, at its tip, there's a glowing knot of ionized oxygen. It's probably there because it got shocked and heated from the black hole moving and hitting the gas. Or maybe this could be radiation coming from the accretion disk. This is not the only unusual black hole traveler that decided to take a different path in life. Astronomers have found another wanderer, a black hole, completely on its own for the very first time. Big stars can explode and turn into black holes, but in most cases, these black holes have star companions. When they come in a binary system, they interact with their partner so you can find them easier because of the light around them. That's why finding this solo traveler wasn't easy at all. It just didn't give off any light. But the Hubble Space Telescope did a pretty good job of finding how the gravity of this sneaky black hole bent light around it, similar to how a magnifying glass does. It's cool that we found something like this because it tells us there could be more of these loners that prefer traveling alone, hiding in the dark. These black holes sound scary, but the comforting thought is they're very far away. Take this lonely wanderer as an example. It's 5,150 light-years away from our home planet. But in 2020, scientists thought that they had found the closest black hole to Earth, only 1,000 light-years away from us. It was really big news until they realized they had actually fallen for an optical illusion. They thought there were 3 giant things over there. A big star making a circle around a black hole every 40 days, with one more star whose orbit went way farther. But it seems it was just a system of 2 stars orbiting each other closer than expected. But we've still got something cool to observe, because they're so close that one of the stars is pulling the atmosphere off the other. Yup, stars have their own vampires too. This vampire star is way bigger and spins faster than the other one. This results in an illusion that they're orbiting each other farther apart than in reality. Still, if I had to choose between these vampire stars and J114 in our galaxy, I'd definitely choose them. The latter one is a terrifyingly big black hole about 3 billion times heavier than our Sun. Our planet is not even a crumb in its morning bowl of cereal since it eats chunks of matter as big as the whole Earth every second. We're talking about the brightest and fastest growing black hole we've seen in the last 9 billion years. What's also fascinating is that this black hole devours matter so quickly that its boundary, which we call the event horizon, is really wide. You could easily fit all the planets of our solar system inside. The cool thing is also that its event horizon is so bright, even amateur astronomers with good telescopes can see it if they look for it in the right part of the sky. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists from the European Southern Observatory's Gaia mission spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest black hole to our planet ever discovered. The nearest one is called Gaia BH1. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of about 9.6 times that of the Sun. It means that it's way smaller than the newly found black hole. Gaia BH3 is located in the Agila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Okay, we can probably admit that this stellar black hole is just a small fry compared to supermassive black holes like the one that dominates the center of the Milky Way. I'm talking about Sagittarius A star. This space giant has a mass of 4.2 million times that of the Sun. While a stellar black hole forms when a star collapses, supermassive black giants have their own ways of seeing the light of day. They are usually the result of mergers of progressively larger and larger black holes. We'll talk about that later. First, let's speak a bit more about how stellar black holes form. When stars near the end of their lives, they typically inflate, lose a lot of mass, and cool to form what we know as white dwarfs. Such massive stellar black holes as Gaia BH3 are believed to form when a star doesn't contain heavy elements and loses not so much mass over its lifetime. Such stars are called metal poor. Afterward, instead of cooling into a white dwarf, this star collapses into a black hole. The companion of Gaia BH3 is a very metal poor star. It suggests that the star that collapsed and formed BH3 was metal poor too. Astronomers know of about 50 stellar black holes in the Milky Way. Some black holes are larger than others. You see, the universe is filled with black holes. Some of them are sprinkled randomly throughout galaxies. Others, those giants we know as supermassive black holes, sit at the center of galaxies. While stellar black holes are usually just a few times bigger than the Sun, such space monsters can weigh from 1 million to 1 billion solar masses. But even though they're so much heavier than our star, they're packed into a relatively small area. On a cosmic scale, of course, the size of our solar system or so. Some astronomers think supermassive black holes could form by several stars colliding and collapsing at once, while other experts state that such space objects might have started growing several billion years ago. At first, a small seed appears somewhere out there in space, which then gradually increases in mass to form a black hole. This seed does it through the process of accretion, which basically means gathering more and more matter around itself. Besides the absence of any precise information about the formation of black holes, there's also the black hole information paradox. If a black hole has some mass, and as we know, these spaced objects have a lot of it, then, according to the first law of thermodynamics, it should have a temperature. And according to the second law of thermodynamics, it should also radiate heat. Stephen Hawking showed that black holes are supposed to emit radiation too. These days, this kind of radiation is called Hawking radiation. It should form at the boundary of a black hole, but after proving it, Hawking pointed out a paradox. If a black hole is capable of evaporating, some of the information it contains can be lost forever. The problem is that the information contained in thermal radiation emitted by a black hole gets degraded. It doesn't repeat any information about the matter swallowed by a black hole before. Such an irreversible loss of information contradicts one of the basic principles of quantum mechanics. Physical systems that change over time cannot create or destroy information. It means we must be missing something. Both physicists and mathematicians have tried to come up with different ideas, but they ended with pretty weird results. Some have even claimed that the universe could be holographic. It means that the universe that we know and love is actually the result of some mysterious interactions at the infinitely distant boundary. I told you, black holes are really strange. At the same time, we have definitely found space objects that seem to have the properties of black holes. For example, look at this image of black hole M87 star. It certainly looks like a physical object, but what if black holes don't exist at all? There's an idea that black holes are actually gravastars, a blend of gravity, vacuum, and stars. This theory was first proposed in 2001 by Emil Matola and Pavel O. Mazur. They hypothesized that at one point during the collapse of a large star, intense gravity might transform its matter into a new state. It's similar to what occurs when atoms are cooled to such low energy states that they start acting like a single superatom. When we speak of gravastars, a star might collapse to the point of the event horizon, or the point of no return, and then its matter is transformed into a new state. It exerts enough outward pressure to prevent the star from collapsing into a physics-defying singularity. In gravastars, an ultra-thin, ultra-cold, and ultra-dark indestructible shell surrounds heavily wrapped space-time. This new form of matter turns out to be very durable, but it's also a bit flexible, like a bubble. So anything that's trapped by the intense gravity of a gravistar and smashed into it gets obliterated and then assimilated into the shell of this bizarre space structure. One of the benefits of the gravistar theory is getting away with those messy paradoxes connected with information and singularities. But even though this idea sounds kinda cool, it doesn't explain the phenomena we observe. And we've definitely observed something that looks like black holes. On the other hand, look at this shadow. It isn't caused by the trapping of light in the event horizon. It's a slightly different phenomenon known as the gravitational redshift. It makes light lose energy when it moves through a region with a powerful gravitational field. So, potentially, it could be a gravistar. When the light emitted from the regions close to the alternative objects reaches our telescopes, most of its energy is already lost to the gravitational field, which causes the appearance of this shadow. And still, like with black holes, things get complicated when you add rotation to the equation. Many experts are sure that gravastars would not be able to remain stable during rotation. But wait, it gets even more bizarre. There are suggestions that the insides of gravastars could contain a series of thicker shells. Those are known as nestars, something like a matryoshka doll. Of course, these theories aren't perfect yet. Astronomers still have a lot of work trying to build functioning models. There's also a chance that both black holes and gravastars exist. But then, we've got another problem on our hands. How can we distinguish between the two? Some theories suggest that these different kinds of space objects should also emit very different gravitational radiation. It could allow us to figure out whether we're looking at a gravistar or a traditional black hole.
Imagine a giant star, a space object with ginormous mass, collapsing down into gravitational singularity. This is a region of space where the density of matter becomes infinite. In such areas, the standard concepts of space and time don't have any meaning anymore. No wonder such objects have captured our imagination. These days, we even have a few photos of black holes, or rather, the space around them. The first photo of a black hole's event horizon was taken in 2019. The event horizon is a point of no return on the outskirts of a black hole. When something, for example matter, radiation, or light, reaches this boundary, there is no way for it to escape. We can use the event horizon to estimate the size of the black hole. The larger it is, the more massive the black hole you've come across is. An international team of scientists that consisted of more than 200 astronomers had been working for years to get this result, and eventually their efforts paid off. The black hole, the region around which they managed to capture, is about 55 light-years away from Earth, at the center of the galaxy M87. People saw this amazing image thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it was tricky. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. But even though now we kind of know what a black hole looks like from the outside, we haven't figured out what might be waiting for us on the other side. Many people imagine black holes as bizarre portals to other worlds, dimensions, or parallel universes. We'll get back to these theories a bit later. So, why not jump into a black hole and go all the way to the other side? Unfortunately, such an escapade is bound to end tragically. If something gets close to a black hole, there's no escape. You might argue that you don't need to go back. After all, you want to explore what's ahead. True, but there's another problem. The force of gravity around a black hole increases dramatically the closer you come. It even creates the effect of spaghettification, when an object gets stretched into thin strands of space pasta due to the effects of gravity. Once spaghettified, the matter then gets pulled into the black hole's orbit and flattened into a swirling and glowing disk of material. And eventually, this matter settles into a nice orbit around the black hole, quite far away from the point of no return. And that's not how you want your space adventure to end. Well, I don't. Getting something to cross the event horizon isn't as easy as it may seem. The material needs to be pushed out of its stable orbit around the black hole. In other words, something must make it fall in, just like it happens with the Sun and Earth. Despite the star's enormous gravity, our planet doesn't get pulled towards it, right? One of the few reasons why the material might cross the event horizon is collisions between particles. By crashing into one another, they gain some energy, and that's enough to send them spiraling into a black hole. An object entering a black hole is instantly transformed. From the outside, it would seem as if the object starts moving more slowly, because time distorts near the event horizon of a black hole. From the perspective of the object falling into the space monster, it would take an infinite amount of time for it to become a part of the black hole. When it happens, its mass will be added to that of the black hole. But even if you somehow manage to survive entering a black hole, you wouldn't be able to come out on the other side. Now, I might disappoint you right now, but black holes don't go anywhere. There aren't any holes involved. And these space phenomena aren't even black, or at least that sort of black. Black holes might seem inky because even light can't escape their clutches, but this has nothing to do with their color. Anyway, when you cross a black hole's event horizon, all paths lead to the singularity, even if we talk about a photon of light moving directly away from it. But the main problem here is that singularities are mathematically impossible. That's why some scientists suggest that when all this weird stuff happens inside the black hole, its mass gets linked to the expansion of the entire universe. And such a black hole is like a rubber band, stretching along with the universe as it expands. And as it stretches, its energy increases. And since mass and energy are proportional, the mass of the black hole increases too. But this new mass creates a pressure that makes the universe expand even more. That's the reason the universe is expanding faster and faster all the time. Wow, that sounds insane. Then, there's also a theory about parallel universes, and this multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, we live in a bubble that is just one of many other bubbles. And these bubbles constantly pop up and vanish. And guess what? Right, black holes might be tunnels between these universes. Or rather, not tunnels, but wormholes. This idea that black holes could be wormholes leading to other galaxies or universes has been around for some time. It gained some fresh ground in the 1980s when a discussion started about whether an object could physically travel through such a tunnel. But since there's no firm evidence that a black hole can allow for such a passage, this remains just an idea. But if black holes lead to other galaxies or other universes, there must be something opposite to them on the other side. That's where the concept of white holes comes into play. So far, white holes are only a theory. You can imagine them as black holes in reverse, or as a ball that falls to the ground and then bounces up again. In other words, everything that falls in bounces and comes out through the white hole. But how might white holes form? One of the theories speculates that a white hole might be a black hole that has almost collapsed in on itself and then exploded outward again. What if, inside a black hole, there's a long tube that keeps getting longer and narrower until it reaches the point in which it gets so narrow that quantum effects make it bounce back? And then the super long and super narrow tube is getting thicker and wider again, and we've got a white hole on our hands. But then, what could make a black hole want to turn itself inside out? According to quantum mechanics, many things we perceive as continuous are granular, Even light is not a continuous wave, it's made up of photons. So if we apply quantum mechanics to space itself, we'll find out that the cosmos is granular too. It means a black hole can't squeeze stuff down to infinity. At some point, it will reach its minimum size. And this matter, or whatever is falling down the black hole, will have to stop and bounce back, giving birth to a white hole. What matter would such a white hole spit out? Some experts think it could be ordinary electromagnetic radiation. It would be unrecognizable from what originally fell into the black hole, since things get horrendously squashed after entering black holes. And while black holes have an event horizon, white holes would have a reversed event horizon. It would prevent anything from entering a white hole. And because of this feature of white holes, if you decided to travel to one, you wouldn't be able to even get close to it. Despite how much we already know about black holes, there are things that are still a mystery. For example, these space monsters seem to gain weight even when there's nothing for them to feed on. This realization might shed light on mysterious dark energy, but I'll talk about that a bit later. Most supermassive black holes lie in the centers of their home galaxies. You can probably say that they sit in the gravitational driver's seat. Meanwhile, hundreds of billions of stars, planets, and moons orbit them. Even though black holes are really, really big, physics makes it almost impossible for them to grow. But we've found one of these space wonders that has swollen to really unimaginable proportions. The black hole I'm talking about is Ton 618, and it's a mind-boggling 66 billion solar masses. The thing is so massive that astronomers had to think of a new term to describe it. They came up with an ultramassive black hole. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a Ton 618. So the question is, how did this ultramassive black hole turn into such a behemoth? You probably know that black holes are made of matter packed together as densely as possible, to the point where gravity gets so powerful that not even light can escape it. And still, it doesn't mean that black holes are some kind of space predator, roaming galaxies and munching on everything they come across. Ton 618 still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. What I want to say is that the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try to do it and you'll see. First of all, the material needs to get close enough to be affected by the black hole's gravity. And that's not so easy, considering how vast the universe is and how relatively small in size black holes are. But if something does get close enough, there's no escape. That's true. The force of gravity around the black hole increases dramatically fast. It even creates the effect of spaghettification, when an object gets stretched into thin strands of space pasta due to the influence of gravity. Once spaghettified, the matter then gets pulled into the black hole's orbit and flattened into a swirling and glowing disk of material. Eventually, this matter settles into a nice orbit around the black hole, quite far away from the point of no return, also known as the event horizon. By the way, we can use the event horizon to estimate the size of a black hole. The larger it is, the more massive the black hole you've come across is. Interestingly, getting the matter to cross the event horizon will be the most difficult part if you decide to grow yourself a black hole. You'll need to push the material out of its stable orbit around the black hole and make it fall in. As an example, we can take the Sun and Earth. Despite the star's enormous gravity, our planet doesn't get pulled toward it. And the main reason why the material can cross the event horizon is collision between particles. This way, they gain some energy, which is enough to send them spiraling into the black hole. But what happens afterward? The center of the black hole likely collapses into something called a singularity. That's infinitely dense material crammed into an infinitely tiny point in space. But the main problem here is that singularities are mathematically impossible. That's why some scientists suggest that when this weird stuff happens inside the black hole, its mass gets linked to the expansion of the entire universe. Yep, when it gets weird in space, it gets really weird. Such a coupled black hole is like a rubber band being stretched along with the universe as it expands. And as it stretches, its energy increases. And since mass and energy are proportional, the mass of the black hole increases too. But this new mass creates a pressure that makes the universe expand even more. That's the reason why the universe is expanding faster and faster all the time. But several scientists have suggested that, instead of a singularity, there might be something very different in the heart of the black hole – vacuum energy, which is one form of dark energy. Okay, but what is this dark energy? Everything on Earth and everything people have managed to see in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force counteracting gravity, and it got dubbed dark energy. The European Space Agency's Planck satellite helped astronomers calculate how much dark energy the universe has to contain to explain the way its expansion is constantly speeding up. Scientists have also built models of how many giant stars formed and collapsed into black holes since the beginning of the universe. The conclusion is very exciting. The vacuum energy in these black holes is almost the same as the amount of dark energy that should exist in the universe. The scientists who conducted these experiments don't claim to have found the answer to the mystery of dark energy or to what we could see inside a black hole. But still, their theory is quite plausible. It can be tested with modern computer simulations and new data received from cutting-edge telescopes and other equipment. And now, let's speak a bit about dark matter. What it is and what it consists of. Actually, this is another thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It is dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. There's one theory, though, and it's linked with the hypothetical concept of primordial black holes. Scientists have never got any real proof of their existence, but they think these black holes might be insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes would have most likely evaporated away, but the bigger ones might still be scattered out there in space. Interestingly, these holes might be so small exactly because they popped up right after the Big Bang. The longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes is incredible. Compare the mass 1,000 times greater than our Sun to that of a jelly bean. Yeah, you get it. So, there's this theory that primordial black holes could actually be dark matter. This idea remained unpopular for decades, but recently, scientists have realized there are many more black holes in the universe than they used to think, and it means the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching. At the same time, some scientists argue that dark matter can't be tons of multi-sized primordial black holes. They would collide far too often for this to work out. So, if you have a problem with all this stuff, just ask your nearest scientist, "Hey, what's the matter?"
The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has managed to observe places that are around 13 billion light-years away. But recently, James Webb has outdone itself. It spotted something it wasn't supposed to see. Astronomers using the telescope have detected a supermassive black hole from when our universe was less than 600 million years old. Just a baby. This discovery is the most distant, actively feeding supermassive black ever observed. It's located at the heart of its host galaxy, designated Sears 1019. The black hole is also one of the smallest and least massive ones found in the early universe. It's equal to approximately 9 million suns. It might seem like a lot, but in reality, supermassive black holes often grow to billions of times the mass of our star. But what is so unusual about this find, and why are scientists having a hard time trying to explain it? You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. It happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.5 million times the mass of our sun, are supposed to be seen in the more recent universe. Well, to tell you the truth, scientists have long suspected that supermassive black holes could have existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It has shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust falling inside them. Such swirls are also called accretion disks. The gravitational force of a black hole heats this matter, which makes the disk shine bright like a diamond. Sorry, but that's not all. Strong magnetic fields produced in the process channel the matter to the poles of the black hole, and from time to time this matter is blasted out of there in twin powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. By the way, astronomers were watching the galaxy hosting the unusually old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when the universe, which is around 13.8 billion years old now, was a mere 570 million years old. Besides the main character of this video, scientists spotted two other black holes. Those probably appeared 1 in 1.1 billion years after the Big Bang, and 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. The coolest thing about all these discoveries is that until recently, all research about things that existed in the early universe was mostly theoretical. But now, with the help of the James Webb Telescope, astronomers can not only see galaxies and black holes at unimaginable distances, but they can also measure them. This isn't the only discovery connected with black holes made recently. For example, not so long ago, scientists saw two stars slow down in their orbits around black holes, and concluded it was most likely the result of drag produced by dark matter. It was the first time astronomers might have discovered some indirect evidence that huge amounts of dark matter could surround black holes. Now, about that dark matter. What is it, and what does it consist of? Our universe consists of normal matter, and dark energy. Normal matter, which is everything you can see with your own eyes or with the help of instruments, makes up around 5% of the universe. Since it's such a small fraction of the universe, maybe we shouldn't call it normal? Dark energy takes up around 68%, and about 27% of the universe is dark matter. This dark matter is just one more space thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. This matter is dark, so we can rule out visible stars and planets. It also can't be dark clouds of normal matter. Otherwise, scientists would be able to detect it. Dark matter is not antimatter, since astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. In other words, dark matter is still as much of a mystery to us as dark energy. Anyway, back to the potential dark matter discovered around the black holes. If it is confirmed, it'll be a great breakthrough in dark matter research. What helped scientists come up with this idea is that dark matter interacts gravitationally, influencing ordinary matter. So, a team of researchers watched the orbits of two stars decay by about 1 millisecond per year, while they were circling their companion black holes. The scientists concluded that these changes in speed were the result of dark matter generating friction and a drag on the stars. With the help of computer simulations of the black hole systems, the team tested a model widely known in cosmology. It's called the dark matter dynamic friction model, and it predicts a certain loss of momentum by objects that are gravitationally interacting with dark matter. And guess what? The simulation matched these predictions. The results of this research helped to confirm a theory that had existed for a long time, that black holes can actually swallow dark matter that comes too close. As a result, dark matter gets redistributed around black holes, creating areas with different densities, which can influence the orbits of surrounding objects, like the stars we've been talking about. Speaking of black holes, there's a theory that primordial black holes could actually be dark matter. This type of black hole is hypothetical since scientists have never got any real proof of their existence. Such holes are insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but some bigger ones can still be scattered out there in space. If primordial black holes indeed existed, they could appear because in some regions of space, it was hotter, other regions were cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though, these holes might be so small exactly because they popped up right after the Big Bang. The thing is, the longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our sun's and that of a pea. There you go. Anyway, the idea of the connection between primordial black holes and dark matter, or rather, the idea of them being the same thing, remained unpopular for decades. But recently, scientists have realized there are many more black holes in the universe than they used to think, and it means that the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching.
Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun. and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter, about 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion! Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
Well, it turns out black holes might not be as elusive as we once thought. They might be hiding within stars. In this case, the extra mass of some of these space lanterns could explain weird gravitational effects in the universe. Previously, dark matter was the cause of these phenomena. The black holes I'm talking about might be those itty-bitty ones that appeared at the dawn of time when the universe was just a baby. And they may still be lurking in the hearts of giant stars. A team of scientists say the idea might be quite plausible. Astronomers could detect such trapped black holes by the vibrations they produce on their star's surfaces. And if there are many of them out there in the cosmos, they might function as the very dark matter that holds the universe together. Almost any black hole was once a massive star that collapsed in on itself and became incredibly dense. Black holes have immense gravitational pull. Even light can't escape their clutches. People often think that black holes work like vacuums, pulling space inside. But that's not the case. Black holes can only swallow stuff that is extremely close, usually space objects venturing into their event horizon. That's a black hole's point of no return. Once you cross this border, there's no escape. In 1971, renowned physicist Stephen Hawking suggested another origin of black holes. If we took the thick soup of particles that appeared moments after the Big Bang and the birth of the universe, we'd be bound to find some spots dense enough to collapse and create black holes. Such holes, which got the name of primordial black holes, could range in size from microscopic to gigantic. If they were pervasive and numerous enough, primordial black holes could act as dark matter, knitting the cosmos together with their enormous gravity. And dark matter is believed to make up 85% of all the matter in the universe. So what's the matter? Astronomers have been searching for primordial holes by looking for flashes that would occur when they pass in front of distant bright objects, magnifying their light like a lens. But they haven't spotted even one yet. On the other hand, if a primordial black hole was tiny enough, with a mass like that of an asteroid and a diameter as minuscule as a hydrogen atom, the flashes wouldn't be bright enough to be detected by such surveys. Then the team, researching the phenomenon of primordial black holes, decided to consider the consequences of a universe where dark matter was made entirely out of tiny black holes. They concluded that one of such teensy holes could be dashing through the solar system at any given time. Some might occasionally get trapped within gas clouds, giving birth to new stars, ending up in their centers. The next step of the researchers was to build a model of a black hole existing in the very core of a star, where hydrogen atoms undergo fusion and produce light and heat. At first, they didn't see anything unusual. Even a super-dense stellar core is mostly empty space, and it wouldn't be easy for a microscopic black hole to find matter to consume there. That's why its growth would be incredibly slow. It could take longer than the lifetime of the universe for this tiny hole to eat a star. But what if a larger hole, as massive as the dwarf planet Pluto or asteroid Ceres, appeared at the center of a star? Then it would get bigger in a matter of a few 100 million years. The material would keep spiraling into the black hole, creating a disk that would heat up because of friction, emitting radiation. Once the black hole grew to the size of Earth, it would start emitting even more radiation, shining extremely brightly. It would also be churning up the star's core, and the star itself would turn into a black hole-powered rather than a fusion-powered object. Such entities were dubbed Hawking stars. To cool off, the exterior of a Hawking star would form a red giant. That's what our Sun is likely to turn into as it gets older. But a red giant star with a primordial black hole at its center would be cooler than the stars that have reached this stage through regular means. Such stars are known as red stragglers. To find out whether they indeed host a black hole, astronomers might need to tune into the frequencies at which stars vibrate. Since a Hawking star would mostly affect the interior of the star rather than its topmost layers, the star would thrum with a certain combination of frequencies. The waves created in the process could be detected in a way the star's light would pulse and throb. So, all scientists need to do now is study the already known red stragglers and figure out whether any of them show the characteristic vibrations of a black hole. Now, should we worry about the Sun? Since our star hasn't reached its red giant stage yet, we can't know whether it'll turn into a cool red straggler. What we know, though, is that our star might contain those tiny black holes that formed in the Big Bang. But now, we have no means to check whether they're indeed there. Currently, our star is around the midpoint of its existence, middle age. It creates energy non-stop by fusing hydrogen atoms within its core. Once it runs out of hydrogen in its core, it will enter its red giant phase and begin to collapse. It'll happen in about 5 billion years, don't hold your breath, and the phase itself will last for 1 billion years or so before our star depletes its fusible materials and loses its outer layers. It will leave behind a tiny white dwarf star half as massive as the Sun and around the size of our planet. In some cases, when the gravitational collapse of a star's core is complete, the star remnants turn into a black hole. But that's not the fate awaiting our Sun. You see, our star just doesn't have what it takes to become a black hole. It's not heavy enough. There are a few conditions that can affect whether a star can turn into a black hole, including its composition, rotation, and the processes that lead to its evolution. But the main requirement is still the right mass. Stars with 20 to 25 times the mass of the Sun can potentially experience the gravitational collapse needed to form black holes. In other words, the Sun is simply too small to form a black hole. But what would happen to us if it did? You might assume that if the Sun turned into a black hole, our planet would be doomed to be pulled into it. But do you remember the basics? Black holes aren't giant space vacuum cleaners, just sitting there and waiting for a new planet or star to get their hands on. Mwah. But black holes don't have enough gravitational force beyond that created by their incredible mass. And if the Sun were to turn into a black hole, which will not happen, this hole would still have the same mass as our former star, and Earth's orbit around this newly formed black hole wouldn't change. But all other things would change dramatically. The Sun, which is currently around 432,000 miles in radius, would shrink to a mere 1.9 miles in radius. But you wouldn't be concerned with the absence of the bright yellow sphere in the sky, since you have many more pressing issues on your hands. Our planet's main heat source would be gone, leaving us frozen in the dark. Without this source of energy, photosynthesis would immediately stop, disrupting entire food chains. Eventually, all life on Earth would be extinguished. But rest assured, our hard, barren rock of a planet would continue in its orbit. Oh well. Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on, kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know, time, space, matter, breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole, like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light-years. It would be a cube about 1,000 light-years on each side. For comparison, our Milky Way alone is 100,000 light-years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate.
You already know about black holes, giant space vacuums that pull inside everything in their way. But have you ever heard of a space phenomenon called white holes? And what would happen if these two met and, let's say, collided? Let's hop on a shuttle, venture into space and get to know them better first. As you already know, you can't see black holes directly, even with fancy telescopes that detect light, X-rays, or other types of electromagnetic radiation. But we can see what a black hole does to the things that surround it. For example, when a black hole passes through a cloud of space matter, it pulls everything towards itself in a process called accretion. As the matter is pulled in, it becomes hot and emits detectable X-rays. Or something else can happen. Sometimes a regular star comes too close to a black hole and gets torn apart. A black hole is a super dense object with an incredibly strong gravitational pull that starts stretching the poor star out into a long and thin shape like spaghetti. You've probably guessed it. We call this spaghettification. As the pieces of the star are pulled in, they become hot and emit X-rays. A black hole can choose a different method too, squishing the star and making it flat like a pancake. In the other corner, you have a mysterious white hole. These are less well known because we don't have much information about them. Our knowledge of white holes is based on theories derived from the same mathematical equations used to describe black holes. To witness this battle, you would need to get close to a white hole. But don't worry, at least this one won't eat you and turn you into spaghetti or a pancake. Just like nothing can escape a black hole, nothing can enter a white hole. It's like the most exclusive club in space with no entry allowed. You can see that white hole also has a mass and even spin. There might be a ring of dust and gas around its outer edge, known as the event horizon, which acts as a border separating the white hole from the rest of the universe. While they share similarities, there's one crucial difference. A white hole can release matter and energy, while a black hole cannot. Scientists describe a white hole as the time reversal of a black hole, as if you're watching a video of a black hole played backwards. Things that are already inside a white hole can leave and interact with the outside world. However, nothing from outside space can ever affect the secretive inner world of a white hole. Einstein said that space and time are not flat. They can bend and fold. All because things like stars and planets have mass. A scientist named Carl Schwarzschild figured out how to use Einstein's ideas to describe what happens around a really heavy object. He discovered something called a singularity. It's a point of infinite density, and it lies at the center of a black hole. It's like a tiny, tiny point where everything is squished together, all the matter that the black hole has consumed. The tricky part is that the singularity is so small that it doesn't really make sense in our normal understanding of time and space. Plus, it bends space around it so much that it creates a special area that's cut off from the rest of the universe. We call this area a no man's land, which is basically where black holes exist. Scientists still can't understand what happens at the point of singularity in black holes, let alone white holes. So let's go back to the questions we started the story with. What's stronger, and what would win then? It seems black and white holes have completely different strategies. A white hole is a mystery that we still don't know much about, but it seems more experienced at conquering space than a black hole is. I mean, a black hole swallows matter and everything it encounters, true. But a theory suggests that white holes may have once been black holes. They're purely imaginary for now, but stories say white holes can only exist if there is absolutely no matter inside their boundaries. If even the smallest particle entered a white hole, it would cause it to collapse. That's a significant disadvantage in a potential battle, don't you think? But it's also a really tough task to try to sneak a small asteroid inside a white hole. Its gravity is most likely extremely powerful and will push you away. This is where the singularity comes into play. Remember when I said scientists were not sure what really happens with this tiny, tiny dot of infinite density? It can't be that a black hole just infinitely collects matter in its center. Something else has to be happening there. What if this singularity kind of rebounds and actually becomes a white hole? Of course, it would take a really long time for this to happen, like billions of years, even for the smallest black holes. There's a special type called primordial black holes, and scientists think those probably formed right after the universe was born. And if there were really tiny black holes created after the Big Bang, they might have already exploded and turned into white holes. Some scientists even think white holes could possibly explain the Big Bang, since both involve an enormous amount of matter and energy appearing out of nowhere. All this doesn't sound promising for a black hole. Can this be the first time ever it's gonna lose? If a black hole becomes a white hole, it doesn't even matter how much it's consumed. It might throw everything back out into space. In that case, a white hole might not last that long, so it will need to make a move against its opponent really quickly. Whoa, you may have thought you were safer near the white hole because it wasn't about to eat you. But look at it! It's shaking! Oh no, it started ejecting all the things it's been keeping inside at the speed of light. Get out of the way to not have some ripped planet catapulted in your direction. After millions, even billions of years of making a mess all around the universe, a magnificent, spectacular, and chaotic battle is about to start. The black hole is patiently taking the attack, pulling in everything that the white hole is throwing in its direction. Asteroids, all those ripped stars that used to shine so brightly in the night sky, planets, and even entire galaxies, it's all getting out of it insanely fast and in all directions. Both the white and black hole have managed to survive against every space object till now, but that's just because they haven't faced each other yet. It's an exhausting battle that doesn't stop. All odds were against the black hole at the beginning. But look, it seems something is changing. The white hole is slowly losing energy since it can't swallow any new things and renew its supplies. Meanwhile, the black hole is patiently collecting everything its opponent has thrown at it during this fierce attack, growing bigger and bigger. It can keep doing it for thousands of years. Its insanely strong gravity brings the white hole closer, even though it's trying to escape. And the time comes for the last strike. The black hole's gravity starts stretching its enemy until it swallows it entirely. The white hole is completely gone, and now that it has so much energy, our winner is more massive and stronger than ever. Oh no! Run! Now you have this hungry supermassive black hole wandering around looking for more things to eat, until it falls apart into a white hole again one day and starts an even bigger, more magnificent battle that the entire universe will watch.
This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, this signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy, coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss, because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. and none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles and light waves start bouncing off this gas, which disturbs the signal a little bit. So when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our Sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom! We've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from 2 stars smashing into each other. What could be more epic than that? A collision of 2 stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker, like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future. It was early morning on the 30th of June, 1908, when a terrifying explosion occurred in the sky above the stony Tunguska River in Siberia. It left 80 million trees flattened, and the affected territory was more than 820 square miles. Thousands of people within 900 miles experienced the Tunguska event, and later, researchers managed to collect more than 700 accounts. Most reports mentioned a fireball in the sky. It was glowing like a second sun. People also spoke about a series of explosions that produced frightful sounds. Sometime later, the ground started shaking as, according to some witnesses, the earth opened wide and everything started falling into the abyss. Was that what really happened? Scientists aren't 100% sure. The indigenous Yakuts and Evenks, for example, believe that a deity sent the fireball to get rid of our world for good. At the same time, numerous meteorological stations in Europe recorded both atmospheric and seismic waves. Days later, weird phenomena were observed in the sky over vast territories, reaching Europe. Those were glowing clouds, colorful sunsets, and even a weak luminescence at night. Some reports mention a blue tube in the sky. International newspapers were speculating about a powerful volcanic eruption. Some scientists thought it could have been a cosmic impact. Unfortunately, it was hard to access the region where the event had occurred, which prevented further scientific investigation. In 1921, mineralogist Leonid Kulik got interested in this story after reading a newspaper article that claimed that passengers of the Trans-Siberian Railway had seen the impact. There were even claims that some of them had managed to touch the still-hot meteorite. Kulik organized an expedition and traveled to the city of Kansk. There, he studied the reports about the event everything he could find in the local archives. It turned out that the story about the train passengers seeing and encountering the meteorite was a hoax. But Kulik and his team didn't give up. They traveled to the region, following first the Angara River and then the Tunguska River. Then, on April 13, 1927, the researchers discovered a huge area littered with rotting logs. Some extremely powerful force must have flattened them. Shockingly, only at the epicenter of the blast, in the forest of Tunguska, some charred trees were still standing. But the most baffling thing was that even after exploring the entire area, the team didn't find an impact crater or any meteor material. So, in the fall of 1927, Kulik's report was published in different national and international papers. The scientists suggested that an iron meteorite could have exploded in the atmosphere, causing the observed powerful explosion and following devastation. He explained the lack of an identifiable impact site by the swampy ground. The soil could have been too soft for the impact crater to remain. So, despite the lack of physical evidence, Kulik called the event Filimonovo meteorite. Filimonovo was the railway station where people saw an ultra-bright light in the sky. Only sometime later did the incident get its name, Tunguska event. Even though this event is quite popular all over the world, scientific data describing it is sparse. Since 1928, more than 40 expeditions have explored the site. They took samples from the soil, rocks, trees, but the results were always ambiguous. Some seismic and air pressure wave registrations, which were recorded right after the blast, are still intact. Plus, about 30 years after the event, researchers mapped the area of the destroyed forest. But since there's almost no hard data, like a crater or a meteorite, and the accounts of the incident are conflicting, many theories of widely varying plausibility have appeared over the years. Among them, there was an asteroid skimming the atmosphere of our planet, and a primordial black hole passing directly through it. Wait, what? At the current age of the universe, black holes form when huge stars run out of fuel and collapse under their own gravity. In other words, there's a limit to how small a black hole can be in the current universe. It has to form from substantial amounts of mass gathered in one small region of space. Plus, it can only occur to stars around 20 times the mass of our Sun and larger. But primordial black holes are something else altogether. Their existence hasn't been proven yet, so they remain purely hypothetical. Primordial black holes could have formed in the first few seconds of the existence of the universe. At that stage of its development, all the stuff that would later continue to create stars and galaxies were packed together much more tightly. At that time, pockets of hot material might have been dense enough to form various black holes, from giant to teeny-tiny ones. The masses of such holes could have been 100,000 times smaller than that of a paperclip. At the same time, these holes could have reached a mass of 100,000 solar masses. Soon after, the universe started to expand very quickly, and it also cooled down. This put an end to the conditions favorable for the formation of primordial black holes. Unfortunately, we haven't detected any such holes yet. But if they formed right after the birth of the universe, it's possible that they might still be somewhere out there. And there's an idea that primordial black holes, smaller than an atom, might be passing through Earth every day without harming our home planet. A larger primordial hole might also visit us every once in a while, every 1,000 years or so. After learning more about the Tunguska event, a team of physicists published an article in a 1973 Nature paper that the event itself could have been caused by a primordial black hole passing through the planet. The researchers stated that a black hole with the mass of a large asteroid could explain the lack of a crater or any other physical evidence of the impact. Blue light noticed by witnesses seemed to fit this theory too. According to the team, in such a case, most of the radiation from the shock front would be in the ultraviolet vacuum. It would then get absorbed and re-radiated at longer wavelengths. There would be just a bit of hard X radiation, and the accompanying plasma column would look deep blue. Admittedly, it's a very unusual theory. But the team also suggested a way their idea could be tested by looking for signs of an exit wound on the other side of the planet. You see, if a black hole entered Earth, the rigidity of the rock wouldn't allow for any underground shockwave. Because of the black hole's high velocity, and because it would only lose a tiny fraction of its energy while passing through our planet, it would follow almost a straight line through the planet. Such a potential exit could provide a check for the entire hypothesis. The team also suggested looking for shock waves and disturbances in the ocean on the opposite side of the world. But there's a problem with the idea of a black hole passing through Earth. Such a black hole could settle into the core of our planet, and its gravity would allow the black hole to start feeding, eventually devouring our entire world. Plus, there would be a lot of heating. You see, during its passage through Earth, the black hole would gather a lot of matter, and this process would produce a lot of heat. To put it simply, the impact of an asteroid-mass black hole would release almost the same amount of energy as the impact of an asteroid, like the one that destroyed dinosaurs. Luckily, according to the existing calculations, the chances of a black hole settling in the core of our planet are minimal, since black holes are just too fast to do so. In any case, the Tunguska event being a black hole passing through our planet is certainly an exciting idea, but no evidence that could prove it has been found yet. Plus, we still don't know whether primordial black holes exist at all. Yep, it's something to ponder.
About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There's no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be all right. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into 2 equal parts, but fortunately, they don't fly away from each other. The moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the moon and then flies away. Now, the moon is definitely breaking into 2 parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the moon got to them. So, moon rocks are flying around the planet, and people see half the moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the moon was closer. There were ebbs on the opposite side. But now, this schedule is wrong. Half of the moon attracts less water. Yes, the moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story ends because the video ends. I'm sorry. Good night."
It was a quiet and clear night in the countryside as a lady slept peacefully with her dog calmly at the end of her bed, when suddenly a loud crash woke her. Something fell through the ceiling. The dog began barking at the sudden loud noise of the unknown intruder. As the lady gathered her senses and wiped her face, she turned on the light. She looked around her room trying to find the cause of the noise. She was shocked and confused to see a great hole in the ceiling. And directly below, right next to where her head was just lying, she saw a rock the size of her fist. Shaken, she immediately called the responsible person as she thought, but he advised that the rock was likely from a nearby construction site. This added further confusion as she was in the middle of nowhere. Nothing could have caused this to her knowledge. The next day, the responsible people visited to investigate. Further, the more detailed analysis showed that it wasn't just any rock, but a meteorite. Did you know that the chances of getting under a meteorite are about 1 in 250,000? It seems like relatively good odds. However, just for comparison, the odds of meeting a shark is 1 in 3.5 million. Do you often fly by plane? Perhaps you fancy your chances with the weather. Being caught in a tornado is a possibility of 1 in 13 million. And if you are a bit of a risk taker, the chances of you winning the big lottery is 1 in 292 million. So, given the odds, it would appear that a meteor fall would be a pretty common occurrence. Yet there are very few known instances of anyone getting by one. The Canadian woman who received the unexpected guest was lucky that it was a small stone. In 2013, an asteroid entered the Earth's atmosphere to the territory of the city of Russia with a population of 1 million people. Little did a cab driver realize, as he drove his cab, that an asteroid entering Earth's atmosphere was the most prominent object from space to enter Earth's atmosphere in over 100 years, measuring 66 feet wide. Everybody knows asteroids are gigantic objects revolving around our sun that aren't planets or moons. They're made from rocks and dust and come in all kinds of weird shapes. The largest is at about 329 miles in diameter. Asteroids mostly live within the asteroid belt between Mars and Jupiter. You can imagine what a journey it made to the Earth on that day. Given that the asteroid belt is so extensive and populated with all sorts of debris, collisions between objects are very likely. As the objects collide with one another, their trajectory changes, leading them outside of the asteroid belt. And on that day, it launched them in the direction of our planet. The city taxi driver dropped off his fare as the asteroid entered the atmosphere. The man saw many people on the street pointing to the sky. He got out of his cab and looked in the same direction. He saw a long tail of smoke across the sky with a bright object at the head of it, hurtling towards Earth at an unimaginable speed. As the atmospheric pressure slowed and heated the asteroid, causing it to glow brighter, it sped towards Earth. The man, unable to turn away, stood mesmerized. He watched on as the asteroid became brighter and brighter until it became brighter than the sun for a moment. The man turned his head away and covered with his arms to block the flash, as it was too blinding to look directly towards it. But as the asteroid reached its peak luminosity, it broke apart into several pieces that then continued falling towards the ground. Startled, the man looked around. The people on the street were also standing silent and unsure of what had just transpired. Suddenly, they heard multiple loud bangs in the near distance. The Earth shook as the falling pieces of the asteroid hit the Earth. Windows within buildings surrounding the street shattered. Cars parked had their alarms activated by the vibrations. Some people ran, but others in the street stood frozen, looking around at one another, still trying to make sense of what had just happened. The ground affected was extensive, covering up to 60 miles wide. Windows were shattered throughout the town. As the dust settled and repairs were made, scientists analyzed the pieces of the asteroid to identify where it had come from. They found that a collision within the asteroid belt had indeed caused it, and this 66-foot intruder was only a tiny piece of an even more giant asteroid. Given the crowded location when the asteroid fell, it was a miracle that no one was physically hit. There has only been one case where a meteorite had made physical contact with a person. It happened in 1954 in the USA. A lady was relaxing on her sofa, enjoying a short nap, when suddenly she was woken by a jolt in the side of her belly. The asteroid had been noticed by many in the same area. Reports were recorded that it had been the size of a basketball as it fell towards Earth. But after it burned up in the atmosphere and crashed through the woman's house, it had shrunk significantly by the time it made contact with her. After it was confirmed it was an intruder from space, the American lady then became the first and only recorded person on Earth hit by a meteorite. Within the asteroid belt, the asteroids also share their home with comets. Comets share the same ranges in size as the asteroids, but they're mainly made of ice. They can also have bits of rock and dust within their body. Comets have a long tail following behind them, which is made from their interaction with the Sun. Comets aren't only located within the asteroid belt. They're well known to have all kinds of paths, not only restricted to just within our solar system. Some sightings of these periodic comets are documented in human history, appearing on infrequent occasions as they make their long journey throughout the solar system. Most notably is Halley's Comet, which can be visible on Earth on average once every 76 years. The last one was about 36 years ago. The first known record by humans of Halley's Comet was as far as 240 BCE. Halley's Comet is next expected to say hello in about 40 years from now. So make sure you get your telescopes ready. Asteroids and comets are big and scary for sure, and we all know that the dinosaurs were not able to detect the asteroid that impacted the Earth, which ended their reign on this planet. But luckily for us humans, we have scientists carefully observing our solar system. Asteroids and comets are so large that they can be easily detected, so there's nothing to be concerned about soon. Now that we have the concerning space rocks out of the way, let's move on to their smaller relatives, the smallest being meteors, made from rock and dust that are so small that they burn up within our atmosphere, having no impact other than a light show. Meteor showers provide the most exciting display for all your novice astronomers out there. Meteor showers are very common, occurring around 30 times per year. They're easily predicted when to occur. You'll just need to ensure you're outside of the city on a clear night and be sure to bring a blanket along with you. But why do we get meteor showers, and why are they so easily predicted? Well, it all relates to how the comet gets its tail. When the heat from the sun interacts with the comet and separates gases and pieces of the comet, the Earth then orbits into the path of that same debris, which creates the magnificent display of the meteor shower. Being that meteors are too small to reach the ground of the Earth and burn up in our atmosphere, what if they could reach Earth? Well, they would then be called meteorites, made up of the same ingredients as meteors, but ultimately, we would only find solid rock if we happened to come across them. What's interesting about meteorites is that they are pieces of an ancient puzzle that have been flying around space for millions to billions of years. They could even been flying aimlessly in space longer than our sun has been burning brightly in our sky. Our solar system will continue to provide more surprises for us to learn from. Just like the asteroid that arrived in Russia in 2013, which scientists only overlooked due to another asteroid that was being monitored closely on the very same day. But as we continue to have these experiences, we will continue to learn from them. And hopefully, when the next big one flies by, we'll be ready. Meteorites rain down on Earth every single year. Almost 63% of the 69,268 meteorites scientists have officially recorded in the Meteoritical Bulletin database have been picked up from a polar desert. From where? Antarctica. It's technically a desert because it gets little precipitation. The continent receives an average equivalent of about 6 inches of water annually, mostly from snow. The interior parts are even drier. Not much action happens to meteorites there. Deserts are like safe storage closets for them, and it's easier to spot meteorites there. In total, there are around 42,000 meteorites in Antarctica. Most of them have been spotted since 1976. The Sahara Desert in Africa isn't far behind. Nomads and treasure hunters have discovered over 14,000 meteorites there, especially since 1995. Then there's the Arabian Peninsula, mainly Oman, where they've unearthed about 4,200 meteorites. So why does Antarctica take the crown for its meteorite collection compared to other areas? It's not because more meteorites land there, Statistically, they can land anywhere. Antarctica wins because it's great at showing off these space rocks. The icy environment keeps them in mint condition. The contrast between the ice and space rocks makes spotting meteorites easy. Plus, there are spots called meteorite stranding zones, where the geology, ice flow, and climate team up to gather meteorites. Here's the sci-fi part. Satellites help researchers find meteorites. They use these space gadgets to spot the best places to search. Some of these meteorites are ancient, like 1 million years old. Now, when you think about how many meteorites there are, it's a bit like a pie chart. If you measure their weight instead of just counting them, things get interesting. Antarctica's slice of the pie gets smaller. On average, an Antarctic meteorite weighs about 2 ounces, like a small bar of chocolate. Ooh, chocolate. But in the Sahara, they've got all sizes, so the average is about a pound. Now, let's talk about meteorites in action. Only a tiny bit, maybe just 1.8% of all meteorites found have been seen falling. These are called falls. Clever name. Meteorite detectives, or meteoriticists, get all excited when they see that. The other 98% are finds. Someone stumbled upon them without seeing the meteorite take its cosmic leap. So when we only look at the ones that fell from the sky, most are called stony meteorites. These are like regular fellas of the meteorite world, but there's also a special kind called iron meteorites, or just irons. There are also super rare meteorites, called mesositerites, and pelocities, that are like a mix of metal and regular rock stuff. In places where humans live, like North America, people tend to find more iron meteorites than those that fell. That's because iron ones are usually bigger and more eye-catching. Farmers found some of these while they were working in their fields. Oh, surprise! A bunch of gigantic iron meteorites from places like China, Namibia, and the US make the chart slices huge. Now, check out this adventure. A group of scientists braving the crazy cold of Antarctica's icy desert to uncover some fresh meteorites found what they had been looking for. In fact, one of the meteorites weighed almost 17 pounds. The ones like that are pretty huge. Do they have an impact on Earth? Science says yes, they do. Meteorite impacts are more common than you think. About 17 meteorites smack Earth's surface every single day. Since most of the planet is covered with water, there are loads of places without people around. That's why these hits often go unnoticed. Most meteorites are just small bits zipping through our atmosphere anyway. By the time they touch down, they get tiny thanks to all the friction against the air. Not all meteorite impacts are wimpy. Some supersized ones have rocked our world. Remember when dinosaurs said bye-bye? Yeah, that might have been the fault of a huge asteroid. These meteorite hits are random, and they happen all the time. Scientists have uncovered evidence of a massive meteor impact even before the famous dinosaur wipeout. This impact is thought to have triggered the biggest extinction event in Earth's history. The 300-mile-wide impact crater is chilling over a mile beneath the East Antarctic ice sheet. This mega event occurred about 250 million years ago. The epicenter of the crater is in the Wilkes Land area of East Antarctica. It might have started the breakup of the Gondwana supercontinent. It was a big landmass that included parts of what are now South America, Africa, Antarctica, Australia, and more. So, the Gondwana supercontinent started to chip off by creating a tectonic rift that pushed Australia northward. This Wilkes Land impact surpasses the one that led to the dinosaurs' extinction in terms of scale and could have caused catastrophic consequences at the time. The Hoba meteorite is a huge chunk of space stuff chilling on Earth. It crash-landed about 80,000 years ago in Namibia. The thing is a heavyweight, like twice the size of the next biggest meteorite ever found. Interestingly, it also has a weird flat shape. Nobody's moved it since it fell, so we really don't know how deep it's hidden. But experts think it skidded along ground like a stone skipping on a lake because it landed at an angle. That's why it didn't leave a big crater when it hit the ground. And it was discovered by chance. A farmer found the world's biggest single meteorite. He was plowing his field with an ox and a regular plow. Suddenly, he heard a scraping noise. It was the metal plow meeting the iron meteorite. The Mosey meteorite from Tanzania has been staying underground for centuries before scientists gave it a proper look. The locals loved this space gem, calling it Commando. It was known in town for generations. Mosey is made of the same stuff as its other meteorite friends on Earth, about 90% iron and 8% nickel. It weighs 25 tons. Let's talk about the El Chaco meteorite, part of the Campo del Cielo meteorite crew in Argentina. Imagine an almost 24-square-mile playground for space rocks. El Chaco, weighing 37 tons, decided to show up fashionably late in 1969. So, what if you found a meteorite? How can you tell for sure that it's not just some random rock? These space visitors have a few features that make them stand out from regular rocks. Firstly, meteorites are often heavier than they look because they're packed with heavy metals and dense materials. Secondly, most meteorites have some metallic iron, so magnets usually stick to them. If you've got a rock that's not magnetic, try suspending the magnet from a string. The third clue lies in their unusual shapes. Iron-nickel meteorites aren't smooth and round. Stony meteorites usually have a thin, crispy crust on the outside. It looks as if their surface melted a bit while moving through the atmosphere. Sounds like pizza to me. Suppose these tips won't help on your quest. Then consider this. Light-colored crystals are not meteorites. Those pretty things, like quartz, are common on Earth, but they don't hang out on other planets or moons in our solar system. Do you know those bubbly holes in volcanic rocks or melted metal slag on Earth? Meteorites don't have those either. Plus, scratching a meteorite shouldn't leave a mark. But if you scratch a dense rock and get a dark or red mark, the rock contains minerals like magnetite or hematite, which meteorites don't usually have. If you suspect finding a meteor in your backyard or something, try these tips. Just remember, to be sure, you've got to give rocks and minerals a real-life look from experts. And if you see one falling towards you, always remember to duck.
Imagine wildfires raging across the continent. than the eruption and tsunami in Tonga in January 2022. The hit would have also produced shockwaves equivalent to a magnitude 6.5 to 7 earthquake. It would have triggered underwater landslides, as well as a series of tsunamis. In any case, discoveries of such terrestrial impact craters are always a big deal. They're quite rare. Researchers have found fewer than 200 confirmed impact craters on Earth. Almost all of them have been discovered on land. There are also several likely candidates, but their origin hasn't been confirmed yet. What can the newly found crater be if it wasn't left by an asteroid? It could be a collapsed volcanic caldera, or it could be a salt diapir, which is a squeezed body of salt. To confirm that the Nadir crater was created by an asteroid strike, scientists need to drill into the formation and gather samples. The evidence scientists are looking for might be shocked quartz, a mineral that appears when asteroids crash into our planet. If we do find it, we'll hopefully learn whether this discovery has any connection to the Chicxulub. Its fall led to terrifying consequences on Earth. The asteroid is believed to have come from the outer reaches of the solar system. When it crashed into the planet, the force of the collision was so powerful that the space rock didn't stop until it got through Earth's crust to a depth of several miles. The impact left a crater more than 100 miles across. Thousands of cubic miles of solid rock instantly turned into vapor. The crash set off a series of natural disasters that erased around 75% of plant and animal species on Earth. Animals that were close enough to see the crash didn't survive for longer than a few seconds. Close to the impact crater, the ground was covered with thousands of feet of hot ash, grit, and rubble. Several seconds after the collision, everything for many miles around burst into flames. What didn't burn down within the next several minutes faced a different, even more terrifying problem. The asteroid also produced a monstrous, largest ever tsunami. A recent study claims that it was thousands of times larger than any wave people have ever seen. You see, the splashdown was so powerful that it left its signature on the face of our planet. In 2021, researchers found out that the collision had carved mega ripples into the Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists even remodeled the events of the first 10 minutes after the impact. And the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. And of course, all that empty place didn't stay empty for long. The ocean gushed back to fill the crater, but in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall and moved at a speed 10 times greater than more distant tsunami waves. During the first hours after the crash, the sky was almost totally dark. Later, it started to get lighter, but very, very slowly. For the next couple of years, the world seemed to be stuck between a cloudy day and twilight. Lots of plants didn't survive this dimness and the absence of sunlight. The ash stayed in the air for months. That's why when it rained, the water became highly acidic. Fires kept raging. They produced tons of toxic gases that destroyed the ozone layer, at least for some time. The gases and particles that had been flung into the atmosphere blotted the sun out. This caused temperatures to plummet by over 60 degrees Fahrenheit. Lots of plant and animal species that managed to survive the impact itself couldn't stand these new hostile conditions. By the way, the infamous asteroid could have also been part of a shower since there's some evidence that many other space rocks smashed into the moon at approximately the same time. In December 2020, some glass was found on the moon. It could have been forming there over billions of years as the soil was ejected during asteroid impacts. The discovered glass was delivered to Earth by the Chinese National Space Agency's Chang'e 5 lunar mission. Researchers have concluded that the super tiny glass beads were indeed created by the heat and pressure of meteorite impacts. It means that their age should be the same as the time of the collision. Using the glass beads, scientists managed to create the timeline of such collisions. They think the timings of asteroids hitting the moon could mirror the impacts of asteroids hitting our planet. Even more exciting, scientists have found out that the age of some lunar glass beads coincides with the age of some of the largest impact craters on Earth, including the Chicxulub impact crater. If this theory about smaller impacts accompanying large impact events on our planet turns out to be true, we'll get important information about asteroid impacts on Earth and the inner solar system. Now, researchers are planning to compare the data received from the Chang'e 5 samples with other samples of the lunar soil from different craters. It may reveal new evidence about what impacts may have influenced life on Earth.
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, Only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our Sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the Sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The Sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. From tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called a halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub Impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub Impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub Impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub Impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They in turn generate tsunami waves as high as the Empire State Building. 5 minutes after the impact, the meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ramp. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion, or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth. Hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory. Traveling back in time now, this used to be hard. We fly past the Middle Ages, the first human civilization, the ancient ancestors of the first humans, the dinosaurs, the first land animals, the ancient sea creatures, and so on to the very beginning of all time. And there it is! This nebula is our solar system. Right now, it's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shockwaves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees. And there's a liquid core around the solid one. It creates the magnetic field of our planet. Now, when radiation from the sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far, our planet is burning and looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point, another protoplanet appears on the horizon. It looks more like an asteroid, the size of Mars. And this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while, all of this debris comes together to form the Moon. As a result of this collision, the Earth began rotating too fast. A day now lasts about 5 hours instead of the usual 24. But the Moon is heavy enough to slow our planet's rotation with gravity. Now, the Earth doesn't look like a hospitable place. The gravitational forces of the Moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on the surface. Ow! The gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates. The vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several 100 million more years, Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen to breathe. The sun wasn't as bright as it is now. Plus, the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago, the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow, warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years throughout the Archean eon. They left stromatolites. These are stone pillars at the bottom of shallow, warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first, this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus, at this time, the first algae appeared, which also produced oxygen. This event is called the Great Oxidation Event, good name, which caused almost all living organisms to disappear from the face of the Earth. For simple organisms, oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later, these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean eon ended with this catastrophe about 2.5 billion years ago. At the same time, continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent. But for now, methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth. But the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Huronian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago, our planet was like a ball and lava, but now it's like a block of ice. Earth, during the Huronian glaciation, was more like Jupiter's satellite Europa. There, too, is a thick crust of ice, under which there's a liquid ocean heated by the core. The evolution of the sun saved our planet. Since its birth 4.5 billion years ago, it's been getting bigger and hotter. So, after 300 million years of an ice age, the Earth began to warm up. But almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Miravia. 750 million years ago, that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges, and fungi weren't the only inhabitants of the ocean. This is Sprigina. They're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic Eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved, having not only an internal but also an external skeleton, like trilobites. Some of these things could reach nearly 3 feet in length. Their protective shells suggest that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannotia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia, and Eurasia. One of the largest sea creatures ever, the Dunkleosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large SUV. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building. And for the first time in Earth's history, some animals leave the ocean and go on lands, such as L. generpeton and Ichthyostega. Anyway, at first, they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold and more evolved land animals began to appear. Gradually, they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs, as we know them, appeared and started a new page in Earth's history. Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs like Triceratops had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash. 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made phytoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of phytoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1 million years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. This hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much later came the iPhone. You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid's surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. but it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth.
Space is vast, dark, and empty. So, wait, what's that? Is it a sphere? Huh? That looks like something like a whitish soap bubble floating in space. Zoom in. A bit more. Do you see people inside? They look like ants dashing around, doing their own things. Someone is growing food, someone is working in the lab. What kind of a sci-fi fever dream is this? Now, all this might not be as unrealistic as it sounds and looks. Right at this moment, Max Space is working on inflatable space habitats that could make living in space possible and cheap. Their biggest habitat would be as roomy as a sports stadium. They've already shown off their plans, claiming that such habitats could help humanity move off Earth in the future. According to one of the founders, there isn't enough living space in space. And if we don't make it cheaper and much, much bigger, we're not going to get very far in space exploration. As for expandable habitats, they are clever. At first, they're small enough to fit on a rocket, but once they're in space, they inflate to create a much bigger living area. For example, one of such habitats with around 3,500 cubic feet of space would cost way less to make than a traditional metal module of the same size. For comparison, the ISS has about 13,700 cubic feet of living space, so this is a big deal. Similar space habitats already exist. A company called Bigelow Aerospace launched 2 test modules, Genesis 1 and Genesis 2, back in the 2000s. And another module called Beam has been attached to the ISS since 2016. Sadly, Bigelow closed down in 2020. But now, Max Space is taking the tech to the next level. They're using a totally new design to make their habitats expand reliably and on a much larger scale. They're planning to test them in space soon. In 2026, they'll send up a module the size of 2 suitcases on a SpaceX rocket. Once it inflates, it'll have about 700 cubic feet of pressurized space. They've already built a full-size prototype to test on the ground and are now making the real thing for space. While this first one won't support people, it'll have the same strength and shielding powers as future human-rated habitats. Colonies on the Moon and Mars, floating space habitats. Everything seems to be all about space exploration these days. NASA, along with space agencies from Canada, Japan, and Europe, is working on something called the Gateway Program. It is basically a plan to build a space station that will orbit the Moon. Meanwhile, billionaires are busy dreaming up colonies on Mars and Venus and even launching space tourism projects. If these ideas actually work, they'd be our first step towards living in space. But there's one problem. If we want to survive out there long term, we need to figure out how to produce kids in space. Should it be natural ways? Are we going to start using special technologies? Space reproduction is super tricky, and the biggest issues are radiation and gravity. That's where Spaceborne United, a company from the Netherlands, comes in. They're working on solutions for this. They've built a tiny IVF and embryo incubator that's ready to be tested in space. Just recently, they've dropped it from about 12 miles above Earth to see how radiation affects organic materials. The CEO of Spaceborne United has explained that their goal is to figure out if conception and early embryo development can happen in space. If we're serious about settling on Mars or other planets and making those settlements fully independent, we'll need to solve this reproduction issue. For example, Mars has way less gravity than Earth, and no one knows if that's enough for embryos to grow properly. Spaceborne United is starting by studying how partial gravity, like what Mars has, might affect development. It's still early to speak about some results, but at least we've started moving in this direction. Even if we deal with the space kids problem, what about other earthly things, like plants? Photosynthesis has had a massive impact on Earth. When organisms started using sunlight to make energy, it triggered the Great Oxygenation Event. It filled the atmosphere with oxygen, allowed multicellular life to develop, and even formed the ozone layer, which protects us from the sun's harsh UV rays. Thanks to that, life was able to move onto land. But how would plants grow under the light of other stars? Our sun is a G-type star, called a yellow dwarf. It feels like a typical star to us, but it's actually pretty rare. Only about 7 to 8% of stars in our home Milky Way galaxy are like it. And since most stars aren't like our sun, scientists studying habitable planets are focusing on more common types. K-dwarf stars, for example, are smaller than our sun, about 50 to 80% of its mass. But they're more stable and last much longer, up to 70 billion years, compared to the sun's 10 billion years. That's a lot of extra time for life to evolve. Despite this, researchers have often focused on M-dwarfs, aka red dwarfs. They're the most common stars, but they have their own issues, like frequent flares. In a recent study, researchers have simulated the light from a K-dwarf star to see how two photosynthetic organisms would respond. They chose garden cress, a fast-growing plant often used in salads, and cyanobacteria, a tough microorganism that can survive extreme conditions. The goal was to see if photosynthesis would work under K-dwarf light. Then, they put watercress seeds in 3 different conditions: sunlight, simulated K-dwarf light, and no light. The plants under sunlight and K-dwarf light grew similarly, but the seeds under K-dwarf light actually sprouted a bit earlier and had slightly larger leaves. It means that plants could potentially thrive under K-dwarf light just as well as they do under sunlight. So, K-dwarf stars seem like a great option for finding habitable planets. Unlike M-dwarfs, they don't have intense flares that could harm life, and their habitable zones are far enough out that planets wouldn't get stuck in tidal locking, where one side of the planet always faces the star. K-dwarfs also become habitable sooner in their lifetimes because their harmful radiation drops off faster than that of M-dwarfs. But how about this? What if life doesn't actually need planets to survive? That's the idea 2 scientists from the University of Edinburgh want you to consider. We've always assumed planets are crucial for life because they provide the right conditions: liquid water, temperatures and pressures to keep it liquid, and protection from harmful radiation. But what if life itself could create those conditions in space? The researchers suggest that ecosystems could generate and maintain the conditions they need without needing a planet. Life could create barriers and structures to keep water liquid, let in light for photosynthesis, block harmful UV rays, and even maintain the right pressure and temperature. And all of this in space, far from any planet. These barriers could work in regions between 1 and 5 astronomical units from the Sun, which includes areas closer to Earth and Mars. Gravity and planets might not always be necessary for stable environments. Biological systems might be able to do the job themselves. Earth is a perfect habitat for life, not only because it has water and a protective atmosphere. It's also an interconnected system where energy from the sun powers everything. Essential elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur cycle through the planet thanks to such processes as volcanism and plate tectonics. Outside Earth, things get trickier. Take the icy moons in our solar system, for example. They might have warm, salty oceans beneath their surfaces, but do those moons have nutrient cycles like Earth? And can they keep water liquid or maintain an atmosphere? These small, cold worlds don't get much energy from the sun, have no way to hold on to their atmospheres, and are exposed to harmful UV radiation and cosmic rays. For life to survive beyond Earth, it would need to adapt to these challenges or modify its environment. And if their idea is true, then perhaps life doesn't just adapt to its environment. It could also create entirely new ones. It was supposed to be an easy 8-day-long mission. 2 NASA astronauts couldn't even imagine they would get stranded in space for at least 9 months. Their task was to test a brand new spacecraft, Starliner. They were hoping to return it to Earth as soon as possible so engineers could check it out and send it on a new flight. But from the very start, it didn't go as planned for Butch Wilmore and Sunita Williams, experienced astronauts who had both been to the International Space Station before. They were supposed to depart on the 6th of May, 2024, but had to postpone departure for 1 month because of a leaky valve in the upper stage of their rocket. When they finally took off on the 5th of June, new problems started before they even got to the station. There were failures in some of their thrusters and, later, leaks in the gaseous helium. It's important because it keeps the thrusters pressurized. Boeing, who built the new spacecraft, and NASA focused on solving those problems and figured out it wasn't safe for the astronauts to fly back home on the Starliner. They didn't just leave them on the ISS, of course. NASA came up with a plan where Butch Wilmore and Sunita Williams would come back home on a SpaceX Crew Dragon spacecraft. It took off in September of the same year with 2 empty seats out of a total of 4. The only problem is that it wasn't supposed to come back until February 2025 at the earliest. In a press conference from the International Space Station, Wilmore and Williams admitted it was heartbreaking to watch their spacecraft depart without them, but they were trained to expect the unexpected. They keep receiving messages of support from Earth, and they aren't at all sad to spend more time in space, as they say it's their happy place. Mr. Wilmore gets up every day at 4:30 in the morning, and Miss Williams at 6:30. They do at least 2 hours of exercise at the space gym every day to reduce the loss of bone density. Another big problem is sleeping in space. The space station has 6 tiny sleep pods, each about the size of a phone booth. Inside, there's a sleeping bag, a little storage area for snacks and personal stuff, and even 2 laptops attached to the walls with bungee cords. The pods aren't completely soundproof, so astronauts sometimes wear headphones to listen to music or calming sounds from Earth to help them fall asleep. But here's the problem. There are more astronauts than sleep pods, so 3 astronauts have to find other places to sleep. One of them sleeps in a simple backup sleep chamber inside the European Space Agency's Columbus lab. Butch Wilmore is roughing it in just a sleeping bag inside the Japanese Space Agency's lab. When they planned this mission, Butch was only supposed to sleep like that for 8 days, which didn't sound that terrible. Another problem they had to deal with was that they didn't pack enough clothes for several months. So, astronauts had to savor what they brought for the first 2 months until a resupply vehicle delivered fresh outfits along with hardware, fruits, and vegetables. The astronauts have a super packed schedule that's managed by a computer tablet. It tells them what tasks to do, when to take breaks, and even when to eat, all in 15-minute chunks. A little red line on the tablet moves through the day in real time, showing them if they're on track or running behind. At first, Butch and Williams were working on the Starliner spacecraft, testing all its systems like communications, life support, and power. Once they finished that checklist, they started helping the other crew members with science experiments and maintenance tasks. The best-case scenario is now a late March return, and if it actually happens, the Starliner crew will spend over 270 days in space. An average mission on the ISS lasts around 6 months, so it's already way longer, but not close to the record time. The current American record belongs to astronaut Frank Rubio, who stayed in space for 371 days in a row. He lived on the International Space Station from September 2022 to September 2023. When Frank first went to space, the plan was for him to stay there for about 6 months, but it didn't go as planned. In December 2022, a meteoroid, or maybe a piece of broken satellite junk, crashed into the spaceship that was supposed to bring him and his 2 crewmates home. The spaceship was damaged so badly that it wasn't safe to use anymore. The 2 astronauts who were on that spaceship also had to stay on the ISS with Frank for 6 extra months until another spaceship went to space and rescued them. During his mission, Frank Rubio zoomed around Earth about 5,936 times. Altogether, he traveled a distance of 157 million miles. It's like going to the moon and back 328 times. Frank also went on 3 spacewalks and spent 21 hours outside the space station. One of Frank's big jobs was to do scientific experiments. He studied how bacteria behave in space, where there's no gravity pulling things down like on Earth. But his favorite experiment was taking care of a tiny tomato plant and watching it grow. Frank admitted that being away from his family for so long was really hard. But it's not the only possible hardship on such an extended space stay. Space agencies have entire departments that study the effects of space on the human body. In one of the studies, called Twins, scientists compared 2 identical twin brothers, Scott Kelly and Mark Kelly. They're both astronauts, but for this study, Scott spent a year on the ISS and Mark stayed on Earth. By comparing them, scientists could figure out how space changed Scott's body compared to his twin. He said it took him at least 6 months to feel like his usual self again after coming back to Earth. Scientists noticed predictable weight loss and bone mass loss, but they didn't expect to see changes in his DNA. They found that his telomeres, which are like tiny protective caps at the ends of DNA strands, got longer while he was in space. But sometime after he got back, he had more short telomeres than before. It looks like the damage was permanent. It must have to do with radiation, which is one of the biggest dangers for astronauts who stay in space for a long time. It can damage DNA, and that can increase the risk of some really serious health problems. Astronauts need protection from radiation, not just while they're flying in space, but also if they live on the Moon or Mars someday. Scientists are working hard to find ways to keep astronauts safe from this invisible danger. Every space agency has rules about how much radiation astronauts can safely handle during their careers. Another big problem astronauts face is bone demineralization. It happens because there's no gravity in space pulling on their bones like there is on Earth. Without that pressure, their bones start losing minerals like calcium, which makes them weaker. Astronauts can lose about 1 to 1.5% of their bone density every month they're in space. When calcium from the bones gets into the body's waste system, it can lead to kidney stones. Because of these changes, astronauts coming back from space need time to recover. Another challenge in space is how the body's fluids, like blood, behave. On Earth, gravity keeps most fluids lower in your body. But in space, they float upward. This extra fluid in the head can push on the eyes, which might change how astronauts see. Some even develop a condition that can make it hard to focus their eyes. And sometimes, the changes in vision can be permanent. When astronauts who spend a longer time in space, like Williams and Wilmore, return to Earth, doctors keep a close eye on their health with regular checkups. Scientists expect that their condition is going to be like that of 6-month astronauts.
You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light years wide. For comparison, just 1 light year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around -63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny-tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system.